ax squared plus bx plus c. That's the most generic way that we have written quadratics in the past. And each part of these has, each piece of this allows us to be able to identify certain pieces of what the graphs will look like. For example, one of the first things that you'll always be able to tell when you have quadratic is that it's a parabola. Parabolas either open upward or they open downward. Now, the difference between the two, besides reading the book, maybe writing stuff down, and we're not using calculators right now, guys, so maybe putting those away also would be helpful. Thank you. So, how do you tell whether it's up or down? Do you guys remember? What is it?
Positive or negative.
What's positive and negative?
Positive goes upward and then negative goes down.
You're correct in that, but more specifically, what part of the function means positive and negative? That's what I'm trying to get at. Well, there's only process elimination leaves you A. A. If A is positive, it's up like a cup. If A is negative, it's down like a frown. Okay? What happens here then is that you also get, do you guys remember a thing called the vertex on these? The vertex? The vertex is where, let's say it's a positive value, so it's up like a cup. As it's decreasing, and then as soon as it gets to a certain point, it starts increasing. Bless you. This value is called a vertex. Bless you. When it is up like a cup, that vertex is the minimum. It's the minimum value. The vertex is a minimum. Therefore, when the vertex is down like a frown, it is its maximum. Bless you. It's the largest value that you can get versus the smallest value you can get. Now, the other thing that you can always be able to decipher with when it's in the standard form is when you work with that c value. For example, if x is 0, c becomes your what? Think about the graph. Yeah, it becomes the y-intercept. The value of c will always become the y-intercept here. Okay, the c value becomes the y-intercept. That's just by putting in zeros for x. Also, one of the things that you guys have done in the past is that you dealt with what's called an axis of symmetry. Does that vaguely ring a bell? What was it? So, yes, sir. You're very close.
That makes sense.
And that's where it's coming from. Yes, ma'am. And that's where I'm getting towards. Yes, exactly right. So when you have parabolas, they're all, each point on the parabola is equidistant to an imaginary line which goes through the vertex that is vertical. The parabola, therefore, then can fold upon itself and then become just two half sides. Okay? So that's how it works. It's where you get the symmetry from. Every single parabola has this, what's called an axis of symmetry, AOS. Vertical lines are always written as what? X equals or Y equals a number? X equals a number. Okay? Your axis of symmetry is always an X equals a number. Okay? In this case, the axis of symmetry is always found by the opposite of B over 2A. That'll give you your axis of symmetry. That also means that the axis of symmetry is always the x coordinate for your vertex. Always, 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 always. The axis of symmetry is always, so if your vertex will always be the opposite of B over 2A, comma, Y. And to figure out what that Y value is, once you know X, you just substitute it. Is this all kind of vaguely ringing a bell? Bless you. like I said, I know that most of the stuff you've seen, so especially for the standard form. As we get into the other styles, it's newer, but if you go to the idea of understanding what symmetry is, like you were saying, like every point on one side of a parabola is equidistant to the center point from a point on the other side. So if this point's 4 spots away to the axis of symmetry, this point's 4 spots away. They have to be equidistant from one another. That's how you get the folding things to work. A lot of info there. But, this, yep, got all that. Other forms. You have what's called vertex form and intercept form. And we'll go through these separately. It'll be easier to. Vertex form. Huh. H and K.
Horizontal. Vertical.
H's and K's. The value of A here again allows us to tell whether or not it is up like a cup or down like a drum. But throw a couple of sheets. Actually, you know what? If you want to grab a couple of these that we've got in case you want to graph something on graph paper and then save something for your homework, that'd be great. And I've got some more in the back if you need more. And I forgot the whole bunch again. I'm sorry. So vertex form, the value of A still tells you if it's up or down. I'm just going to put a plus here or a minus there. I can just grab a couple. Notice the x minus h quantity squared. X minus h quantity squared plus k. That means that our vertex is going to be located at h k. That means the vertex will be located there. That tells you where is your axis of symmetry going to be. What's your x coordinate? Right. Your axis of symmetry here is at h. The axis of symmetry will always be at x equals h. Let me show you an example of how we would do this. Let's say we have -2 x minus 3 quantity squared plus 1. Then we'll just walk through this one together. When we go to graph something like this, when it's written in this form, I always, and you guys saw this when we did, what was it? Something. Oh, absolute value, I forgot what they were called. Remember how we labeled A, H, and K? I like to do that a lot with everything. I like to label. The more information I put down on paper, the easier it is for me to decipher what goes where. So here, I know that I have an A value. Let's slide this up a bit here. I have an A value that's equal to -2. As soon as I know what my A value is, I know the direction that this has to go. Where does it have to go? Down like a frown. So I'm going to automatically put a little down like a frown next to it. That way I remember, hey, knucklehead, make sure you graph it this direction. Don't screw up. My H and K. H and K are where? 3 and 1. It's 3 and 1 because, yep. Because it's x minus the h, and this is your h value, is 3. If it was x plus 3, then it would be at -3 and 1. K value stays the same, you just reverse that, so your h and k are at 3, 1. That means your vertex is located there, which means your axis of symmetry is at x equals 3. So here's how we graph something like this. Oops, trying to make this just so it fits a little bit better. I apologize. First thing I always First thing I'm going to do is plot where my vertex is, 3 and 1. Okay, I can do that. After that, I'm going to plot my axis of symmetry line, the x equals 3. Since the axis of symmetry is technically not part of the graph, it's there to help us plot points. It's always a dotted line. Did you guys know that? Axis of symmetries are always dotted because it's not technically there. And I know it's got to open downward. So in this case, let's say we don't have fancy schmancy calculators. I need to find some points. First thing I would do is just pick a point on either side of the vertex, like 4. What's 4 minus 3? What's 1 squared? What's 1 times -2? What's -2 plus 1? All I'm doing is plotting points. Notice, yeah, it's just the next point. Because I know that if it's the next one over, it's probably going to be pretty close. If I pick 10, I mean, this could be way down there. I'm going to pick values that are close. Usually I'm going to pick the next 2 values, either to the right or to the left, and just then just substitute in. Because if this spot is 1 away, what has to be here? 1 away. I do it again with 5. And notice, a lot of this stuff is mental math, and the mental math here is pretty easy. What's 5 minus 3? What's 2 squared? What's 4 times -2? Add 1, you get positive or negative? -7. So I'm at 5 and -7, which means I'm over here at -7. That's enough for me. You're on your way. Sometimes you'll get a couple that fit on the graph, sometimes you don't get a couple that fit on the graph, and that's okay. Usually you'll get at least one set, obviously you'll get the vertex, and more often than not, you're gonna get the next set of values. Sometimes that second set of points show up, sometimes they don't. When it comes to quizzes and tests for things like this, like I've said before, I usually don't let you use the graphing calculator because the graphing calculator does everything for you. And it gives you all your repairs, all the stuff. So I usually just give you a cheapo scientific calculator and make you guys label out some repairs. Again, it's nothing too crazy. It's just making sure you guys can math. Vertex form. Not bad, right? Did you guys ever graph out of that form before? Okay. It's just another way that we can do it. Okay, it's just another way. Let's look at intercept form. Intercept form, I think, is really cool. I don't think that worked. Intercept form is